here to speak to you about event-driven big data with Accumulo is John Hebler. John is a principal engineer at Lockheed and tech lead on a project that's using Accumulo, kind of the centerpiece of what they're working on. So with that, turn it over to John. Thank you.
Okay. Well, thanks for making it, especially after lunch. This is my one achievement. I got Jimmy Stewart, Sherlock Holmes, and big data all on the same slide. After that, they're all downhill from there. Does anyone know what movie that came from? Wonderful Life. That's when he wants the big suitcase. But anyway, okay, enough of that. This is my other cool picture, and then I have no more cool pictures at all. But the goal, I wanted to go briefly over how we kind of saw event-driven. I don't want to spend too much time on that, and go more into how Accumulo helped us pull things off, and so really get into the Accumulo level. And then we did a prototype system you could play with on Amazon, and I might have enough time to show you that, but if not, you'll be able to use those VMs that have Accumulo on it. It's all set up and ready to go if you want to play with this. So some of the examples I will show you here are what we implemented in Amazon. So that's kind of the three steps there. Okay, so for as far as events go, we found that a lot of the data processing that we see is kind of batched up somewhere. And the events, if you think of real life, okay, real life, if I punch you, that immediately has a consequence. And an event isn't just data, it's something that changed that's relevant to you. So you might be in the same location all the time. That's not really a new event, even though a system might keep reporting, like your phone might keep saying, you know, I'm in Ellicott City, I'm in Ellicott City. That's not really an event until you switch to your DC. Now I've got an event. So what we wanted to do is look at all of these different source systems that we have that have information that could be turned into events if we recognize change and we recognize to what we're looking at. So that changed the way we did that. We kind of grew up into Accumulo, so we're not internal people that have messed around with the insides of Accumulo. We're really using it to solve some problems that we have. And we started out with a pull system. So somebody came to us and said, I have this question. We would go out to all the source systems, get all the pieces together, and give them a response. So that works fine with a onesie kind of a thing, but now somebody's saying, well, I really have 100,000 questions that I want you to answer simultaneously. And that doesn't work. So then we said, what if we could collect all of the events that are changing? So this could be, if you think about fraud detection, that could be all the purchases you're making, how you're spending your money. It could be sensors in a car. All these are events. So those events pour into a system, and we pre-calculate all the answers. So when somebody comes and wants to know something, it's already there. So now they could ask for 100,000, or they could ask for one, or they could ask for all kinds of combinations. I'll show you a little picture of that. But that also gave us two big problems. First of all, there's a lot of events. Where before in the other system where you pulled it, we only had to get the data we needed to answer that one question. Now we have to have all the events pouring in, and that's where something like Accumulo can handle that. So we can just pour them all into Accumulo and then start looking at things like deltas to see what changed and what truly was an event and what wasn't an event. And the second gift that gives you is now you have this amazing analytic source of all the events that have happened. Where before, I only generated data when somebody asks for something. Now I have all the data pouring in. So another big purpose is all the analytic stuff that we can see longitudinal changes over time because we have all the events. We have all the things that have changed. So what I'm focusing on, not so much as an events, I just got to believe that's a good thing, but more of how Accumulo helped us do certain things with events. Got a few things to cover, so hopefully I'll get it all in 30 minutes. So this is an example of what how architecture works. It could be implemented in Storm, in Hadoop, and parts of Hadoop. We use parts of Hadoop. And also we use RabbitMQ, which is what the Amazon solution uses to do the messaging. So on the outside there, on that candidate space, you have all different data sources. You might have files, relational databases, messaging systems, all kinds of things that have data in them. Some of that data is now data. They know what your bank account is now, or they know where you are now. And that is then translated at the first level there into events. So we start to look at what am I interested in? I might be interested in financial data or travel data or location data, all different kinds of things that I'm focused on. And that first level is basically translating the medium that they're storing the data in with an event that we care about. And an event means that something's changed, something important has changed. So that first level is just a transformation level from some data format that they have to an actual event that we care about. Then the next level tries to take multiple events together. For example, let's say you had multiple sources that were reporting location. So this mixes all the location sources together, and we run an algorithm that says which location do we consider the important one. And that you can have as many of these levels as possible. We have a lot more than this in terms of processing the different incremental pieces. Eventually it all gets to a model of something that's representing an abstraction of something we care about, like the state of a car or the state of your health, collecting all these different events about that. And then that's just always fed by these events in as real time as possible. As fast as those events come in, they're impacting the model. So if somebody turns around on the other side, can start analyzing the model independently of the events. So their performance is completely different than the performance of the events coming in. So they're completely decoupled. So that's how we could get 100,000 requests on the client side and not have it interfere with the events that are coming in. And it's essentially a best effort event. As soon as we get the event, we reflect that in the model, and it's a best effort. So all the things we can collect, we put in there, and we can certainly add new sources, new kinds of events as we go along. We usually collect a lot more events than we'll ever use, and a lot of categories that we won't use because of the analytic value that might be there eventually in the future from a discovery standpoint. Because Accumulo lets us do that. It's funny, now we call it big data, but what are we going to call it next? Because everything before used to be big data. But now we do things like 200,000 records to reprocess those. That's like nothing. I mean, that's literally like nothing. We had to, well, I'll show you how we have rerun some things. But 200,000 used to be a big number. It's not anymore. So I'm hoping that affects age too. As I get older, the number isn't quite as big. But it seems to be getting bigger. Okay, so are all you familiar? This is just to give a background on Accumulo itself, because we're going to talk about a little bit about how we're using these different pieces. Accumulo is a key value store, but it's really important to understand what makes up that key, because the key is the indexing piece. And if you don't get the indexing piece right, you're basically never going to get the query to come back, or it's not going to be stored correctly. And we spent a lot of time how we design the indexes, and which is the key. So you've got kind of a multi-tiered index. So you got the row ID, and the family, the qualifier, then this unusual thing called visibility, and then the timestamp. So that all makes up the key. If you change any one of those things, it's a different key, and it'll be stored in a different place. So for example, if you were using that as an index into another table, if you change the visibility, that index broke. And those are some things you just have to understand how it works. Now, we've gone back and forth in our design as to whether you use those other columns as column names. I mean, there's other family and qualifier as a column name. So the row ID could be some unique number, like that's person 12. And then the column could be name, and then the value is their name, things like that. That's a traditional way to do it. But if you also think about this and the way that they use this key, you have one type of index. You have lexicographical indexing. It took me a while to say that word, but now I can say it pretty good. That's all you got. And it has some strange things where if you say search for the letter A, it's going to get everything after the letter A. That you might not be used to when you're doing other kinds of index methods. But you can also use this as a hierarchical index. So you might have the person and then maybe the time that you saw them. And if you set it up right, you can look for just the person or the person within a certain time. But you have to think about how hierarchical you want to do that. And you can set up more than just these three. You could start packing in more values. You could put all that into the row ID, for example. Stuff like that. So we've done both combinations because if you change one row in here, it's atomic. So if you can pack a lot of stuff in there, you get a nice little transaction. You don't have to worry about partially updating one row over another. So there's some trade-offs in how you do each one of those. And we've done both in our design. We have kind of packed fields where we have maybe 4 or 5 things in the row ID, and then others where we're really using it as just an index with a column. So both of those tend to work. But we've done a lot with the packed fields because then we just get the one row back and we have everything we need. But it all depends on your application. Okay, so that's that. Now, how we set this up, this is a really important concept. This is why I wish I had a laser printer, a laser pointer. I haven't wanted to have one of those, but we have this concept of context. So if you think of events pouring in, and this example, and actually this is what the example uses in the Amazon virtual machine, we have a Twitter feed that's coming in. Twitter seems to be popular. And you have people's opinions about different topics. So for example, you have Anne's opinion about McDonald's, and that's in the event itself, that's where her opinion's stored. It could be a good opinion or a bad opinion. So if I wanted to track what was the last thing Anne said about McDonald's, I'd go to this context table to see if she's changed her mind. Maybe she likes McDonald's, maybe she doesn't like it. If she's keeping the same opinion, then that's not a new event. So that context that's kind of the current view of all of these different authors that are writing things off in Twitter. Now, everything they write is stored in the event table. So every time there's an event that they come across with a tweet, I would store that. So the event table grows based on every event that comes in, where the context table only grows when I get a new author. So the same author will keep being reused. So if I get a new event coming in, I look at the context table to say, hey, is this really changed? So I look up a person and the topic, and I say, is this really a changed opinion of this particular brand? And if it isn't, then I just put it in the event table and I'm done. So I could do some analytics on that, but there's no new event there. They haven't changed their mind about anything. So another example that's used later into the Amazon is I could have a topic context that says, okay, what's the current topic? As I combine all of the authors in the next level, I combine all of their opinions about a brand, and then I keep track of that context and say, what's the current opinion of Google or McDonald's? And is there a change there? And then I could keep passing this on in this context table. So the context reflects the current view of all the events. And that's what I bounce it off to see if there's actually a new event or not. So I'll show you how we use that to do some neat tricks in Accumulo. And you see how this lines up in Accumulo, how we use the key and the values in this. Okay, so there's three kind of categories that how we use Accumulo. I just wanted to break it up rather than some huge laundry list. What are the direct Accumulo things that we had to focus on? How did we do event programming with Accumulo? And how did we manage the events with Accumulo? So kind of three brief areas. So first there was the query. Some of these things I talked about in terms of lexicographical indexing. You never want to search in the value. I know people have actually tried that. I think they're still waiting. If you have lots of stuff. So you really have to think about index, or you got to create a new table. And this is kind of the price you pay with Accumulo to be very fast and efficient. You're not going to get all these creative things that, let's say, MongoDB has to create indexes on the fly and things like that. You really have to think this through. Also, what's a neat advantage, and I'll show you how we use this later, is you can get versions within that row. So you can tell Accumulo how many versions you want to keep of that row. And we use that to our advantage. I'll show you a little later on. And the instructions of how to do that is down below there, where you can set the number of versions it keeps, and then the number of versions that a scan returns. And so you could keep flipping that. So you could say, I only want the latest version, or I want all the versions, things like that. So if you wanted to know what the context was before, I could just get the previous version if there was a previous value there. So we use that to our advantage. And then also batch scanning. We tend to look across a lot of different tables all over the place. And a batch scanner lets you set multiple ranges. And it's extremely fast. The only downside is there's no guaranteed order in how the data all comes back. So you just have to consider that when you're getting your results back. But we use the batch scanner and the batch writer, and we're getting really high speeds on both ingest and on query if you set up your indexes correctly. That's a big step. Okay, so there's some code for that. Event update, and this is another nice thing you can take advantage of. Events naturally fit in append model. Okay, I don't know if anybody goes in Unix and remembers the append mode of a file. If you use append mode, you can have tons and tons of authors, and nobody ever overwrote anybody, because you're always just putting it at the end. And this events fit perfectly with that model, because you're always just getting a new event, you just want to put it on to the end. If you ever want to update the event, all you got to do is keep that same key, and now it will just overwrite the previous value that was there. So remember, this is paying attention to that key. So if you got the right same key, and that author says a new thing, a new event, you can just overwrite that. You don't have to do any deletions or anything like that. Just you do an update. It's really nice for that. Event cursor. This is another little thing we had to come up with. Accumulo, if you do a query, of course you could get literally millions or billions of rows back, and Accumulo will naturally cache that, so you don't use up all your memory. It'll give you just the ones you asked for. So basically, you just have to put a level on top of that when you're bringing back some kind of abstraction like an event that actually helps kind of drill down into that advantage that Accumulo gives. And then you can literally bring in billions of events. Accumulo doesn't know about that abstraction, but using their cursor, you can do that. So that's just some code we did to do that. Visibility. Now, this is one that I heard somebody use the word authorization, but it doesn't work like authorization, and you have to really keep that in mind. It basically says, okay, if you've got this special permission, you can see this row. But that is part of the key. So that key will change based on how you do it. So I could have, let's say I had a calendar, and I had I wanted to have two ways of looking at my calendar. One is for everybody, and they might know right now that I'm busy. And for a private view, they might know exactly where I am and have a phone number and things like that. Well, that would be two different rows in Accumulo. And that means if you have permission to see both public and private, you'd have to have the client distinguish between which is the right one and which is the wrong one, because there's clearly conflicting information. Just have to be aware, it's very powerful, but it's not like authorization where you'd say, I just want to turn off the permission for this person to see that. That would be a new row you'd have to put in because it's a brand new key. And the other key is still there. So you can't just flip a bit like that. And that's just, these are all things that we had to learn as we got used to this. But it's really neat if you use it the way it was meant to. Okay, a little bit about event programming. This is sort of like do what you can and don't ask permission until you find out you can't do it. So it turns out that when we did a lot of the Accumulo programming, it was much easier to try something and then deal with the exception rather than go through all the things of trying to do it right and then seeing that it works. Because there's always a window where the exception can occur no matter what you do. Because when you're dealing with distributed computing, who creates the table, who deletes an update, all these kind of things, just do it, and if you get an exception, handle it. Because most of the time you won't get the exception, so you're much faster. This example actually still has, does anyone see the problem with that example? If you're a Accumulo Java programmer? Yeah, there's another exception when the table operations, and this actually can happen because when you do the create batch writer, it's saying, hey, that table doesn't exist. Okay, so then I go down and try to create the table, but since this is distributed computing, some other one could have also recognized this and created the table before inside that little hole. And so you'd have to catch that. But we found that to be much faster programming in terms of the actual performance, because most of the time you're not going to hit an exception, rather than like checking a flag that everything's set. And even if you have something like that, there's still a window where they're going to have to deal with an exception anyway. So just another little thing there. Transactions. Yeah, this is actually big fights I got in with some of my colleagues that were trying to develop a system. They really wanted transactions. They really wanted to lock things down. You don't want to lock things down. And the funny thing about transactions is you're locking them down, and most of the time you don't need the lockdown. Right? Most of the time it's not going to occur. So how do you avoid this? Well, we found two ways to avoid it. One is we can batch certain things so that you can group things together that you know are associated with each other, like events that have to work together. You could essentially set up a shard so that they all go to the right processor and stay in the right thread. That's one way. The other way is to recognize that a race condition has occurred. Now, how race conditions occur in ours is you get two events, like two opinions might have come in. They're on two different components, two different virtual machines. So neither one knows about each other, right? Because they can't. They're still dealing with it in memory. No one saved it to Accumulo or anything else. And then they process it partially. They wouldn't have the complete answer. And then they deliver that answer to the model, and the model now has two answers in very close time frames that are both incomplete. They're not exactly wrong, but they're incomplete. So what we did, and this is a very rare event, this would happen hardly at all. So what we did is we look at when events come with the same kind of event comes close together, we just send it back through again. So then then everything would be in Accumulo, and if we saw two more events come out then we'd send it back again. And it turned out that was a very rare condition, so it would hardly ever happen. And now we aren't burdened with any transactions through a whole system. So that fits very nicely with how Accumulo likes to be and how if you want high performance with a lot of big data. Another one, and this is another key using the key correctly. If you remember my flow, we go from like one event producer to another as they each work on different pieces. If you can coordinate pieces of the key with each other, you can easily get back without having a back pointer or a back index. Essentially, the key becomes the index into a different table. So each level might have their own table, and then using the whole key or a piece of the key, you can quickly get back. If you have the key in Accumulo, it's like lightning fast. You'll get it instantaneously. If you don't have the key and you have to look for all kinds of indirect stuff, you don't want to use Accumulo. You know, it's kind of how I would see it. So we did this, so this allows us to trace back really quickly using that key effectively. Another trick that we used is by labeling an event a test event, just putting a flag on it. Now we could send in live production. So in a production system, we could actually simulate any situation with different combinations of events, and it would be stored differently, treat it with a different context. Everything would be different, but we're getting real-time performance and real-time reliability statistics right from the actual production system by using a test event. Just a little flag, so just so you use essentially a different set of tables from Accumulo. Okay, now we get to some of the fun stuff that was really hard to figure out for a little while. Is sometimes you might know something, and then, so it's an event. Okay, let's say I just found out that you are in DC. Okay, so that's an event. I now plug that into my model of whatever I'm trying to do with fraud detection, whatever it is. And all of a sudden, whatever that source is says, I can no longer say that about you. I don't know where you are anymore. But you were really in DC. So essentially, I have to turn the assertion off. It was valid, but it's valid no longer. So see, so there's a real date that it happened. I know you were in DC from this time to this time. Now I don't know where you are from that source. So what I would do is I would go into the context. And in this case, we're using the Twitter example. I used to know that Anne had a topic about McDonald's that had a certain opinion. But now, for some reason, she's turned off that opinion. She doesn't have any opinion. Whatever that source was can no longer verify, can no longer assert that that opinion's true. Or the location, I can no longer assert that that location is valid. So what I do is I look at all the other data I might be able to mix with that in the context and create a new event that says this is the answer that I would give now that I no longer know this about that person. So this is where I have to turn off an assertion. So using the context, it can give me that ability. A bigger trick, and this one has a lot of implications for events, was how do I forget an event has occurred? So this could happen is, what if I received an event that's wrong, that's actually incorrect, and I have to remove that event? So think about what that event might have rippled into all kinds of other things. It might have made all kinds of conclusions because of this event. All kinds of things might have happened. So this is a little more complicated. So we have a couple ways of attacking it. First of all, this is where we use the versions in Accumulo. So I can take that value out and see what the previous value was. Now in our particular case, we only go too deep because of our particular domain, but you could go deeper than that. But each time you go deeper, Accumulo is storing that extra data. So you've got to decide whether that trade-off's worth it. So we can just basically take out the value, put in the old value as if that value didn't even exist, and then rerun the current state. So that would tell me the current state. But I still have another big problem. What's my other big problem? All the things that might have contributed to that might be in the model. So this is kind of a neat thing about events. What I can do is go back to my event queue. So let's say this happened, let's say the event that was wrong was from yesterday. And since then, all kinds of events came in. I made all kinds of conclusions. This event might have intermingled with lots of events and made certain decisions that are already out there. So I've got a problem here because I don't just have one thing wrong that I've got to fix. I might have hundreds of things or thousands of things that are incorrect. So what I can do is go back to my event list. So I have all the events. Go back to the kind of events that I want. That might be a certain topic in this case or a certain type of event. And go to a time when this event happened. Because I know the time, and that's one of the things we use in our key is that time field. So we know exactly where it is. So I go back in time. I clear the context. So I just wipe the context out. So it has nothing in it. And then I literally rerun all the events. So it could be 3 days ago, could be 3 months ago. I'll rerun all the events. And actually in our case, this is where that 200,000 came from. We had a situation like that. It says, but we have to rerun 200,000 events. That's a big number. And that took 10 seconds. I mean, this is the kind of, I'm still not used to the speed that you can turn things around. And so that's why this context is very important. I can wipe out my memory. It reminds me of process switching. If you're into process switching, and if you clear the registers and put a whole new set of registers in there, you've now switched from process A to process B. It's very similar here. If I throw away everything in context and then build it back, it doesn't matter whether it was 2 years ago. It's just a matter of time till it runs through all the events. And because I have Accumulo, I can collect all the events. And because I've organized them by time, I can get all the events back that I want. So I kind of rerun them. So I'll watch my time here. Okay. Then that is how I can do time travel with this. So that's my other cool picture. That's all I got. I told one of the guys I work with, if I ever do animation, you're supposed to kick me somewhere and it's going to be painful. So you'll never see animation from me because he's always around looking for me to use animation. But that's about as cool as I get this picture. But time travel is the idea of, because you can wipe out this context with events, now I can rerun things as if they're different. Now, I just gave you one case where there could be an error, but you could do the same thing with a what if. What if they weren't in DC? What if they were in California? Would have that changed the way all the data came out? Maybe it wouldn't have changed, because there's other things that are going on at the same time. So you could do what ifs. You can, say we had this problem with corrupt data. Okay, what if you got a feed that had all incorrect data, but you've already poisoned your data because you've let these events flow in, and now they've done all these things. You can clear out all those old things and rerun them. And now you're back with all the clean data. So we found this to be way more useful than we ever imagined when we first designed this, that we could actually just rerun things when things get into trouble. And that's because we have all the events. As long as you've got the events, you can kind of redo all these things. Okay. Future events. This is the last one, really. This is the idea that sometimes you know something is going to happen, but it might not happen, right? I could say that I'm going to come home on Thursday, but I might change my mind and I might come home Wednesday. So future events are a little tricky. I might get an event that says it will occur. Like travel would typically be this. I might know that you're right now traveling to England, but you're scheduled to come back from England in 2 months. So how do I deal with a future event? Because it's not current, so I wouldn't want it to affect any decisions now, but it might happen. That's the difference between a fact that you get that they are in England versus a fact that they might be in England in 2 months, something like that. So how we deal with this is, first we thought we would create this future event factory and it would keep working on it. But the troubling thing with future events is they might not occur. That's the problem. So what we did instead is we just have a little trigger that registers, in 2 months, I want you to go back and look at the events, and any event that just turned on that moment, I want you to generate it. And so that would allow us that if the event got wiped out or changed, there's no real damage to that. It would just look up the table and see that there's nothing to do. And if there was something, then at that time, right when it turns on, when that alarm goes off, then the event would get generated that now they're coming back from England, something like that. So that was another thing we did with future events. Okay. And then just some other gotchas and issues and things like that. Because we have all the events, we have a tremendously rich analytic base where you could start doing all kinds of questions of how one effect it had a certain aspect on a certain model, because you're collecting all events and understanding all model translations. So you're not just doing when somebody asks. Also, backup and recovery. Accumulo has a really cool feature called cloning and backup, and there's a couple gotchas there, which kind of bit me. So cloning, you can clone a file, a table, I don't care how big the table is, the cloning will take a millisecond. Because all it does is it sets up a mechanism to do a delta between what the current table is and this new table that you cloned. So if I do nothing, they basically point to the same table. If I added something to the main table, that would be noted that it's not added to this other table. So that's what the cloning will do. And so you can immediately clone all of your tables. Then the next step you would do is take them offline, the clone tables offline. So now, then they have something called export. But export doesn't do what I thought export did, which is basically export the file, export the table. What it actually does is set up a list that you could tell another command of how to get all the contents out of that table. And that you have to give to HDFS to do a distributed copy, and then it uses that list to copy it out. So if you don't forget that last step, you get burned because you'll delete the table and then everything's gone. okay, which is exactly what I did about 4 or 5 times, and I'm trying to understand what's going on here. And then you go back down to HDFS, which is another issue that I bring up is, you know, in Accumulo, you have to also be an expert at HDFS and Hadoop and all these other things that are going on, which it's built on that basis. But, you know, if you look at the configuration files for those, there's literally probably 10,000 different configuration options. And typically you'll have a bug and it'll go into some weird things, oh, change this to a 7 or something like that. And that can get overwhelming, and you really need some expertise at that level too, because a lot of times Accumulo will be hurting because of some resource contention that's happening at a lower level. So we found that to be also true. And then right now we're exploring other kind of hybrid systems that kind of try to take advantage of what the different big data sources have and what they don't have. So Accumulo and MongoDB, Accumulo and the semantic web. A semantic web is really poor at big scale stuff, but if you give it a small set and you do some reasoning, it can really do some cool stuff. So Accumulo could be the big one. You pull out a small piece, you put that into ontology, and you could do that. Mongo is much better at discovery-based analytics, where one question leads to another question, leads to another question, and each one is depending on indexes that you couldn't have possibly known ahead of time, because you're kind of discovering this. So that's another kind of combination. Let's see, I think we're almost right on time. So I just want to talk a little bit about this. Down below is the actual picture that we have in EC2. How many people have played with EC2? So do you have your own virtual machine? Because they'll give you a virtual machine for free for a year. It's a small one, but they'll still give you one for free. That's not bad. But I'm still amazed at all the things I can do for like 40 cents. And still, and it's funny, this is a capitalistic thing. I still think, well, do I have an hour's worth of work? I still think about that because that's their increment. And if I only have like 10 seconds, you know, I just want to like get something from GitHub or something like that, oh, I think I'll wait. And it's funny how just a quarter will affect you that. But I do a lot of stuff on there, and my budget, monthly budget is like $8 to $10. And I have all kinds of crazy stuff running on that. And it's so cool to be able to set stuff up. So a little ad, I just think it's really a fun environment for us to kind of experiment and do crazy things. But we have a couple machines set up, and if you send me an email, I'll give you all the directions of how to do that. Let me take it to where, let's see. So one machine, which is this one you're seeing now, that has Eclipse, STS Eclipse set up. It's got RabbitMQ set up. It's got all the software on it. And it also has MongoDB, because we have this prototype runs for both MongoDB and, and Accumulo. So you get that. And then this actually is talking to Accumulo right here. Here's a little Accumulo view of in another virtual machine. So I could give you directions on how to get a hold of these virtual machines, or what the logins are, and all that kind of stuff, and how to actually exercise it if you want to go further and play with this. But we set it up so basically we could learn more about it. But you're certainly, and then all the software is on GitHub too, and I can give you that information also. So I think just a couple minutes for questions. Not yet. I mean, we take in about 6 billion a day of events, but because we can squeeze them down, we haven't hit problems like that yet. But in fact, time's an interesting one, because depending on how you use it, you could get the latest or the earliest, depending on how you set up the key. So we haven't ran into that yet. So I'm sure we'll get there. Oh, have I run into hotspots with using time as an index? But it's only a piece of our index. It's not the first piece. So I think that might protect us a little bit too. We put a lot of time into keys. Got to get the keys right. Yes.
How are you using
RabbitMQ, which by the way I love RabbitMQ, super fast. But that's our inner message between the different layers. But we also have a Hadoop layer that's doing some of the batch stuff, that's bringing in events from a batch. And we still debate about how to move. Should we use Storm? There's other things we've been thinking about. But we started with RabbitMQ, and it's been very nice from an elasticity standpoint. Because, I mean, message-based architectures, which I fell in love with. Everybody knows Tuxedo? You hear Tuxedo? That's a messaging-based thing. I originally started with Bell Labs. It's just such a good decoupled environment, because all those components, we can throw new components if there's a surge, or pull them out, and they don't know any different. They're all stateless. So the only state is in Accumulo. That's the only thing we worry about. But yeah, RabbitMQ, and that's all set up on the virtual machine if you want to play with it. Yeah, in fact, RabbitMQ, see, I think I got that right here. Let's see if I go here. RabbitMQ. So here's, there's nothing running right now, but RabbitMQ is a wonderful web interface. You can do, it's just a really good, the documentation's good, and we've had very good success. We've been using it in production now for a couple years, and we really haven't had any problems at all. We have it spread out. What do you call that when you have multiple copies of the word? Just we have it replicated, and that's all been working. We have it secure, I mean, encrypted, and that's all been working. I mean, it's just been really nice. Really liked RabbitMQ. Other questions? Okay. All right.
Thank you.
Thank you.